next presenter is Mr. Simon McCulchick from Murray, Kentucky. Simon's honors thesis is titled Application of Neural Networks for Intelligent Video Game Character Artificial Intelligences. His mentor, again, is Dr. George Landon from the Department of Computer Sciences here at EKU. Simon is going to be graduating in spring of 2017. Just got the wonderful news. I just want to look about the news for both of you guys. You know where you're going to be next year. Simon specifically has been hired by IBM. You might have heard of them. It's some company. Simon's going to be working for IBM out of Austin, Texas, starting in June. So gainfully upsized and employed. So congratulations on the job. And knowing the work that you've done here at EKU, I can't wait to see these being professional like that. Ladies and gentlemen, Mr. Simon McCulchick.
Thank you. So, that's a really long title. Basically, we're going to play some video games. For my honors thesis project, I developed a video game with Dr. Landon, playing with some of the new bleeding edge technology, like neural networks. They've been around for about 20 years, but recently we're seeing more and more of them in the consumer space and the video game space. So I'm pushing for adding some of these more machine learning concepts in the video game space. But all that aside, we're not going to talk about the math or the complicated stuff. So yeah, it's just a creative project. I made a video game. So the purpose of this creative project was to develop a proof of concept game that demonstrated the effectiveness of neural networks for use in game AIs. So basically I'm trying to take this technology, put it into a video game, and see how it works. So today we're going to talk about what video game AIs actually do, what neural networks actually are, and we're going to play through the game that I made, and we're going to talk about how we use those features in the game, because I don't want to spoil it for you. So, video game AIs. They've been around for a long time, ever since Pong, when we had the two-player mode on the Atari. We've been able to have two-player games with artificial intelligence, so you can play video games by yourself. So now with video games, we want more and more interactivity. We want to be able to play a video game and be challenged intellectually by these artificial means. Because sometimes, not always, people are there for human interactions. So by having better AIs, we're able to increase interactivity, and it makes it a more entertaining experience. However, up to this point, most of the video games are rule-based. So a lot of the AIs are dictated by a set of conditions and actions. If this, then do that. So the Pong game that we saw earlier, when the ball moves up, move your paddle clockwise or vice versa. And by using these two rules, we're able to make a pretty decent AI, and it makes the game fun. It's a lot more fun than just playing Pong against the wall with the three solid walls, because then you're just playing with yourself. And you still are, it's just with an AI instead. A more complicated example, Smash Bros, for instance. So we could think about this in a rule-based manner, and then talk about what some other possibilities are. So, by show of hands, how many of you have played Smash Bros before? All right. So Smash Bros is a video game where we have different Nintendo characters such as Mario, Luigi, Princess Peach, Zelda, Link, all of these characters that we're familiar with in other games, and then we put them in this arena where they can battle each other. So you can make an attack, you can block an attack, you can charge up for a super attack, or various different attack motions. So it's a competitive game, last man standing wins. So if we think about an artificial intelligence for how to develop such a video game, we could say, okay, if the enemy is close, well, I could either attack him, or I could not attack him. I could charge up a smash attack if I think it's a good idea, but if he's too strong, I probably should step back and play it more conservatively. So this is a lot more complicated than the previous rule-based artificial intelligence that we saw. But it still does the job. You can still develop a video game character that exhibits enough intelligence to make it fun. So this is how it's been done in video games for the most part, especially for the smaller game development studios. Larger studios can afford to try out some of the new technology or the machine learning technology that is used in that's been used in industry with neural networks a lot today. But for the most part, these rule-based systems are what you see. So if I play a rule-based AI in such a video game context, there's this notion of predictability. If I'm playing this AI, I'll be like, okay, I'm smart, I know how the AI works. I can find his rules, I can exploit his rules, and then use that weak point to my advantage. If I know when I'm playing Galaga that the aliens will shoot at this interval, I can jump out, make a quick shot, and then jump back in before that interval expires so that I can beat the system. So by using artificial intelligence, it's more of a method of tuning the system rather than specifying exactly how the system is going to work, so that it's more of an art than a set of rules. So this has its good sides and bad sides. By having a specific set of rules, we know exactly how it's going to perform. We can guarantee that it will have at least this performance. But at the same time, it's kind of predictable. So one technique for reducing the predictability is to apply some machine learning techniques such as neural networks. And that's what we're going to talk about today. So neural networks, by the sound of it, sounds kind of like brains and stuff. So we're going to model video game brains after human brains. We think of them similarly. This character has an embodied sentience, and brains will control what's going to go on in their virtual mind. So Neurology 101, we have neurons in the brain. Each neuron's cell body has different dendrites that connect to other cell bodies, and they function as sort of inputs. Whenever there's enough action potential inside the cell body, it produces a signal through its axon to the axon terminals. So yeah, on that side we have the inputs, and then on this side we have the outputs. In computer science terms, we have a set of n inputs and a set of n outputs. So there's a function inside there called the activation function, which basically adds up all the inputs and tells whether or not we're going to send a yes or no. Okay, how is that going to make smart video games? Well, we're just going to link them up in a really complex format. Okay, so it's every circle you see here is one of those neurons. We have all of these inputs and outputs, and we can control various output parameters in our video game based on a set of input parameters from the environment and from our character. Okay? So, now is the fun part. Introducing Dubiety. This is the video game that I created for this creative project. You are working as a ground control station worker for spacecrafts. So you're there coordinating all the efforts, talking to the astronauts, making sure everything's okay, monitoring the system, monitoring the stats, and as well as doing the, I guess, psychological control to make sure that they are not freaking out. So this whole game is all about whether the AI will trust you. Now, trust is a hard concept to describe. So this project is playing with that trust metric, which is determined by neural networks. So once you can get him to trust you, he's going to give you a passcode, and with that you can see the sensors and help him save the ship. So who wants to play video games? So let's play. All right, can everyone read that?